This week we have a combination of earthquakes and interior of the earth and faulting, because they all go together. Earthquakes are when energy from plate tectonics builds up along a weak spot, which is called a fault, and until it finally can overcome that incredible friction for movement to occur. And when that movement finally occurs and that stress that's been building for hundreds or thousands of years finally is released, it releases large amounts of energy, and that energy is called seismic energy or seismic waves. They travel through waves. And there are a few different types of waves. The first two are body waves, and body waves go through the earth. Everything we know about the interior of the earth is by studying earthquakes. We've never even drilled through the crust, but we know about the layers within, because every time there's an earthquake and the waves go through the earth, it's like the earth gets a sonogram and we can see what's inside. So let's define a few of the waves. The P waves are the primary waves, and they are the fastest waves. They are longitudinal waves, which means they have areas of compressions and rarefactions. And because of their nature, they're able to travel through solids and liquids. They're fast and they are adaptable. They can travel through anything. The S waves are the secondary waves, and they are not as fast and they are not as adaptable. Secondary waves are longitudinal waves, the type of waves that have crests and troughs, and the secondary waves are only able to travel through solids. The P waves, the primary waves, are always faster. They always reach the seismograph stations first. And then the third type of wave is called a surface wave. Surface waves are different than these two. These are body waves, so they go through the earth and come out the other side, where surface waves do not. They only travel on the surface, and they're the most destructive because they have both horizontal and vertical components. Surface waves are the damaging waves that make the buildings fall, but they're not that useful to us in science. When the waves arrive at a seismograph station, the first waves to arrive are always the P waves. The secondary waves are always the second spike on the seismograph. And then the surface waves, the last ones, the ones that are all over the place, those are the surface waves. And when geologists want to determine how far away an earthquake is happening from their station, they look at the lag time between the P wave and the S wave. Just like when you were little, if you counted between the thunder and the lightning to tell how far away the storm is. That's because light travels faster than sound, of course. And so the longer it takes for the thunder sound to catch up to the lightning, the farther away the storm is. And that's the same kind of principle, except using computers to determine where an epicenter is. The anatomy of an earthquake, we should just mention, here's a little side view of the earth. This diagonal line is a fault. The actual place where the failure happens, where the movement occurs, this is called the focus. And from the focus, the waves are released. And that imaginary place above the focus on the surface, this is called the epicenter. And this is what we report when we report an earthquake, because that's where the highest level of energy is released, directly above the focus. So how do we know about what's inside the earth? Well, every time you have an earthquake, so here at the top, this is my side view of the earth. Here's my layers again. I have my inner core, my outer core, my mantle, and my crust. And here, this little star, this is going to be my focus. And again, the focus is down under the ground. Above the focus is the epicenter. When the focus releases the waves travel in all directions, the P waves and the S waves. I'm going to draw the P waves first. The P waves, they go out in all directions. And when the P waves hit a change in medium, the liquid outer core, they bend. They get refracted, and then they come back again. And they bend again when they go through the solid core, and they bend again, and they bend. So these are the S waves, and they get refracted when they enter a new medium. As a result of this refraction, there are places on the opposite side of the earth where the P waves do not make it, because they hit the outer core, they get refracted, and they get bent right out of the way. So there's this zone where there's nothing, there's no P waves. That zone where there's no P waves, it's between 100 and 140 degrees away from the focus. And this is called the P wave shadow zone. The shadow zone is kind of spooky because there's no waves here. The reason why there's no waves here It's also on the other side here, the P wave shadow zone. The P wave shadow zone is at this exact location because of the size of the outer liquid core and the refraction of the P waves. The P waves don't get lost, they just get bent because as the wave is traveling through the mantle, it has a certain density, and when it crosses over into the core, the density changes and it gets refracted. As a result, we have the P wave shadow zone. It exists between 100 and 140 degrees away from the epicenter or the focus. The poor S waves, though, the secondary waves, they cannot get through the liquid outer core at all. So when they hit the liquid outer core, they completely die out. So here's my core. If these are my, let's say these are my S waves now, when my S waves hit the outer core, they're finished. They can't go through liquid, so they just completely die out. So as a result, the S wave shadow zone is like a giant smiley face around the entire bottom of the planet, or the opposite side of where the epicenter and the focus. The S wave shadow zone is gigantic, and that's because secondary waves cannot travel through the liquid outer core. And this is how we know we have a liquid outer core. We know the size of the liquid outer core because of where the S waves die out. So this is how we know what is inside the Earth is from studying earthquakes.